so for these, the rules are still the same. It's just a harder problem to do. So we need to switch our x's and our y's. So we will get x equals 5y plus 2 over 3 times y. All right, now, what do you guys think we should do? Okay, we cannot subtract the 2 because of the 3y in the bottom. So I agree that we should multiply by 3y. Because you cannot solve for something that is in the bottom. So if I multiply by 3y here and 3y here, that'll at least get it out of the bottom. So now I've got 3xy equals 5y plus 2. All right, what do you guys think now? Okay. I'm doing what you guys tell me now. We'll see if it gets us anywhere. Okay. Then what? Okay. Okay, have I solved for my y? Is my y by itself? A y is by itself. But do we have another one? And it is not by itself. In fact, are we going to be able to get a y by itself when we have two y's? No, so we've got to somehow get our y's together. So while everything we have done here is mathematically correct, it's really not getting us anywhere because we still have this y over here on the other side. So let's back up to this point. Granger's idea was good. We got to do that. And everything that you guys told me to do was correct. It's okay to do that. It just did not get the y's by themselves. Now, if I had 3y equals 5y plus 2, you guys would know how to do this, right? We could just subtract the 5y and get those together. But we got 3xy equals 5y plus 2, which is going to make this more difficult. So, here is the strategy that you need to use for this. You want to move everything that has a y to the same side. So, we're going to do 3xy minus 5y equals 2. Alright, now, I've got a y here and a y here. What can I do with it? If I divide them, I could divide them. But if I divide them, that means I'm going to have a y over here on the right side, but it's going to be in the bottom of a fraction. And do we really want anything to be in the bottom of a fraction if we're trying to solve for it? No. So, let's try something besides dividing. I can't put them together as a y squared because they're not multiplied together. Cannot. No, because of the other terms with where we got a 3x with one of them and a 5 with the other. Like if it was a 3x and a 5x, we could do that, but we cannot do that here. What if we factor this y out? What if we do y times 3x minus 5? Is that equivalent to the line above it? Right? Because if I multiplied the y back, I'd get 3xy minus 5y. Now I've only got one y. Right? Now, my y's are together. That y is multiplied by 3x minus 5. So how could I get the y by itself? Perfect. cancel that, and I will have y equals 2 over 3x minus 5. Is my y by itself? I don't have any y's over on the other side. I could write this with inverse notation if I want. Okay, so when we see these scenarios where we end up with more than one y, this is a strategy we want to use. Let's try another one here. This time we've got h of x equals x plus 2 times 9 minus y, or 9 minus x. X plus 2 over 9 minus x. So we need to switch x and y's. And like Granger told us on the last problem, we can't solve for things when they're in the denominator. So we need to get rid of that 9 minus x that's in the denominator by multiplying both sides. I'm sorry, 9 minus y, not x. By 9 minus y. Make sure you got parentheses around it because you got to multiply that whole side by the 9 minus y, so you need parentheses. So over here on this left side, I would need to distribute that x. So I'll get 9x minus xy equals y plus 2. So we need to move all the y's to one side, all the x's to the other side. You can move the y's to whichever side that you want. It does not matter. It will affect the way that your answer looks, whichever side you decide to move it to. So like, for example, if I decide I really would rather the y's be over here on the right side this time, because I won't get as many negatives if I do that, that's a perfectly good option. So if I did that, this would need to go to this side. The 2 would need to go to the other side. Whenever you move anything to the other side, what happens to its sign? Flips. So we would have 9x is staying where it's at. Its sign does not change. We have a minus 2 equals y is staying where it's at. It doesn't change. And we'll have a plus xy. And when we've got both y's on the same side, we want to factor out the y. So I have y times 1 plus x. And then what is the last thing that we would do? Divide by 1 plus x. And so we will get, we'll call it h inverse of x equals 9x minus 2 over 1 plus x. Now, you guys don't have to copy this down, but let me just do this really fast. What if we move stuff to the other side, right? So let's say I have 9x minus xy equals y plus 2. Let's say I moved everything over here. I would have negative y minus xy equals 2 minus 9x. And I would factor out a y, and I would have negative 1 minus x equals 2 minus 9x. And I divide by negative 1 minus x, and I divide by negative 1 minus x, and I would get h inverse of x equals 2 minus 9x over negative 1 minus x. Does that look like my answer here? It's kind of similar, but it's not got the right signs. But they are equivalent because all of the signs are flipped, right? Because like what I could do to this problem, let's say I did it this way and my answer choice wasn't there, it was multiple choice. If I multiply the top of this by negative 1 and multiply the bottom by negative 1, is it okay to do that? What is negative 1 divided by negative 1? It's just 1. So it's okay to multiply the top of a fraction by a negative as long as I also multiply the bottom by a negative. And that would give me negative 2 plus 9x over 1 plus x. And then I could write that 9x minus 2 over 1 plus x. And it would match what I had up here. So a warning, if you see these on a multiple choice section, your answer may not always look like the answer. You might have to manipulate it a little bit depending on how you solved it versus how they solved it. There's not really a right way to leave the answer here. You know, both of these ways are fine and could be what they do as the answer choice, but they won't put them both there because they're both correct. All right. I think I'm going to let you guys practice on your own a little bit on these. So we are not going to do example 5 because we've done some practice with that. Those are the same types of problems. All right, what we need to look at for inverses, whenever we are asked to prove that two things are inverses, what we might be inclined to do is to switch our x and y's and solve, right? Our process that we do whenever we prove that things are inverses. But there is a concept that they really want us to understand, and that is the concept that inverses undo each other, right? So, for example, if I have, let me use just like a really simple example where I know these are inverses. If I have f of x equals x plus 2, right? What is f inverse of x? What is the inverse of adding 2? Subtracting 2, right? So, just to show you a little bit about what I'm talking about, if I take any number, let's say I take 5, and I plug it into this equation, I will have 5 plus 2, I will get 7. So, I took 5, I plugged it in, right? I took 5, I plugged it into f, and it gave me 7, right? Now, if I take 7 and plug it into the inverse, right, 7 minus 2, what do I get? 5. It takes me back to what I started with, right? This is going to be true for any number. Like if I do 5 of negative 4, right, I get negative 4 plus 2, which is negative 2, right? And then if I do f inverse of negative 2, I'll get negative 2 minus 2, which is negative 4, right? So what happens in a function, f, you're going to apply your f of x, and it takes you from a number to another, and then if you use f inverse on that number that you got, it'll take you back, right? So what this means is what we're really essentially doing there is we're composing functions, right? We're doing f of f inverse of 7, or f of f inverse of negative 2. So what we can see here is if f and f inverse are in fact inverses, then f of f inverse of x, if we compose those functions, we're just going to get x because they undo each other, right? Whatever we did with f, we undid with f inverse, and we just get x. And it's also the same for if we have f inverse of f of x as well. If you're asked to prove these, it's wanting you to show that f of f inverse of x equals x here. In this case, they have not used inverse notation. We're supposed to prove that these are inverses, and we're doing f and g, right? So I need to look a little more closely to see exactly how these will be worded on AP stuff. To kind of give you an idea. I know it's a topic that we have to cover, but what I'm looking at here is I want you to do f of g of x, right? Which means I'm taking g of x and I'm plugging in for x. So this is our composition of function stuff that we did prior. Okay, so I will have 2. All right, put your computers away, please. And then we got x plus 5 over 2 minus 5. Now, what will happen here when I calculate this? Do I have anything over here that can cancel out? The 2's can cancel because this is like 2 over 1, right? And this stuff is being multiplied together, so that 2 can cancel with this 2 in the bottom. And if it does, then I've got x plus 5 minus 5. And what is x plus 5 minus 5? Just x. The 5's cancel each other out as well. So that works. F of g of x equals x. Now, I have never came across in my 16 years of teaching math a question where f of g of x equals x, but g of f of x does not. However, maybe there's one out there because the rules say that we have to check the other direction as well. So maybe there's one out there. It also helps like if you made a mistake the first way, then the second way may not work and you'll catch your mistake. So we also need to check g of f of x to make sure we also get x for that. Like I said, I've never actually had it not work, but maybe there's one out there. So this time we're taking 2x minus 5 and we're plugging it in for our x here. So that will look like this, 2x minus 5 plus 5 over 2. All right, what will cancel first this time?
The 2's.
Not the 2's, it's the 5's. So the 2's, like if I have something like this, x plus 3 and 3, I cannot cancel those 3's because I've got things that are added or subtracted there. So I can't cancel these 2's yet because of the 5's that are added or subtracted. But I've got 2x minus 5 plus 5. Those 5's are going to cancel. And then I will just have 2x over 2. All right. Now I don't have anything added or subtracted, so I can just cancel the 2's now, and I will get x for that, so that works. Okay, so therefore f and g are inverses. Okay, questions? Let's do one more example with that. This should have a square root that goes all the way across here. It just didn't copy well. All right, so I need to prove that these are inverses. I need to find f of g of x and g of f of x. When you're doing this, label them. So we're showing we're doing f of g of x. Right, so label it. Don't just start doing work. Label it. Which means I'm taking all this stuff and I'm plugging it in right here for the x. So I'll have 3 plus square root. That x gets all this stuff, x minus 3 squared plus 4, and then we got a minus 4. So this stuff right here went right there where that x was. Correct, those 4's is what's going to cancel first here. So I got 3 plus the square root of x minus 3 squared. What cancels next? Square and the square root, which gives me 3 plus x minus 3. And now 3 plus x minus 3, what's that give me? 3's cancel out, and I just have an x left. So that worked. Once again, never actually seen one where f of g of x works and g of f of x does not, but we still have to show it. So g of f of x, this time we are taking f of x and plugging it in for our x in our g of x function. So we're going to have 3 plus the square root of x minus 4 minus 3 squared plus 4. So if we kind of look at what's happening here, this stuff right here is our f of x. We're plugging it in for that x right there. Okay, what cancels first this time? The 3's are going to cancel. So I got square root of x minus 4 squared plus 4. Next, the root and the square. So now I've got x minus 4 plus 4. And last, 4's cancel, and I'm just left with x. So those would be inverses. There is a technicality where the domain would need to be restricted on this that we will talk about later, but we're going to add that in right now. Okay, questions? All right. We're going to do the first part of this first question. It's similar on the second question as well. For this, the first one is calculator active, the second one is not. So, a wind turbine uses the power of wind to generate electricity. The blades of the turbine make a noise that can be heard at a distance from the turbine. At a distance of d equals 0 meters from the turbine, the noise level is 105 decibels. At a distance of d equals 100 meters from the turbine, the noise level is 49 decibels. The noise level can be modeled by the function s given by s of d equals a times b to the d power, where s of d is the noise level in decibels at a distance of d meters from the turbine. So, what we have done so far is what we would have done is we would say we've got like our distance and our s of d, and it told us at 0 meters we've got a 105 decibels, and at 100 meters we've got 49 decibels. Okay, and so we're just putting that into the calculator and doing regression, right? But I did not realize that they were going to ask you this question in the way that Part A asked the question. Okay, so Part A says, use the given data to write 2 equations that can be used to find the values for constants A and B in the expression S of D. Okay, now we did do this one time because I made you do it by hand one time. They are essentially at least forcing you to set up the by hand part by asking you this way. Okay, so for that Part A, number 1, they're asking you to set up equations, and this is how we did when we did this by hand. So first of all, I've got the point 0, 105. So they gave me the equation. It's S of D equals A, B to the D power. So let's use that first piece of information. Whenever D equals 0, S of D equals 105. Right? So if I plug that into that equation, I would have 105 right there for my S of D equals A times B to the 0 power. Now this one's actually a lot easier than the one I made you guys do by hand. Because what is B to the 0 power?
1.
It's 1. So this is 105 equal to A times 1. So what is your A value? It's just 105. Right. You don't actually have to solve it until you get to Part 2, so I guess I could have waited for that. This equation right here set up is what they're wanting, or one of the 2 things they're wanting for Part 1. Okay. The second equation that you're going to set up is going to use that second piece of information. D equals 100, S of D equals 49. So if just like we did on the other problem, we plug that in to S of D equals A times B to the D power, we'll have 49 equals A times B to the 100th power. Now, can you solve that by hand? You cannot. However, they are really, in this part, just asking you to set up these two equations. So that's all you have to have for part 1. Now, it would still be okay, I'm pretty sure, for you to do, because this is calculator active, to still do the regression and find A and B in your calculator. That would be okay. So then if in part 2 of that question you did the regression, you could find A and B. Now let me do it by hand for you here, just because on the second part it's not calculator active. So it is okay to use the regression there, but you basically already found A is 105, right? Because B to the 0 is just 1. So if A is 105, that means we could plug that in here. So we got 49 equals 105 B to the 100th power. Right? How do I solve this equation for the B? What would I do first? Yeah, we got to divide by that 105. And we're definitely using our calculator here. Where's 49 divided by 105. 0.46 repeating equals B to the 100 power. Oh, what do I do to get rid of the 100 power? One-hundredth root. What's another way I could type that in? The 100th root. We could do an exponent to the 1 over 100. So we could do 4.6 repeating to the 1 over 100. Right there. And that's probably the easiest way to type it in, although there is a button for this. So I'm getting 0.9924 is my B for that. So here you have what they're looking for. You got your A and your B. It's the same numbers you're going to get if you do the regression. So you could do the regression on this. But on the second problem, it's going to ask you to do the same thing, and it's not calculator active, so you'll have to do it this way. Okay, which will make it a little bit tougher. All right, so just hold on to that other worksheet that I handed out to you. We're probably not going to do the whole thing, but there are a couple things that I want to look at from it, so we might look at a couple of those tomorrow. Your homework is to do this progress check. I don't have the key posted yet, but I will try to get it posted before I leave today. Yes. Yeah. The worksheet that I handed out, hold on to it, the one that says worksheet B, that is